So, hello everybody, a very warm welcome. I'm Liz Price. I am Deputy Pro-Vice Chancellor for Sustainability at Manchester Metropolitan University, and I also have the pleasure of chairing the Education Committee of the Institution of Environmental Sciences. So, welcome to this panel discussion, Skills for a Sustainable World, Transition, Place and Provision. So for anybody who's watching the recording later, this is part of the Science Council Workforce Skills Conference, which has already involved an excellent series of discussions helping us to think about the skills we need across the science workforce. This panel is going to be looking at the skills we need to create a more sustainable future, how we can deliver those skills, and some of the benefits we can achieve in the process. We wanted this discussion to go beyond the usual net zero skills panel discussions, which often are quite limited and don't always give us what we really need to create a positive change. For me, the term skills is a shorthand for skills, knowledge, values, behaviours, competencies and capabilities, so the whole spectrum that allow people to be change agents for a sustainable future, whatever discipline they study, whatever career or life path they take, and at whatever life stage they're at. So I hope you'll take that framing as sort of implicit. In order to facilitate that deeper level of discussion, we have an excellent panel who are going to start us off with some lightning presentations. So first of all, we're joined by Professor Sian Davies-Follam, the incoming chair of University Geoscience UK, who is speaking on behalf of the UK Heads of Department of University Geoscience courses, and who will be outlining the value of diverse routes of entry into the science sector. So thank you very much, Sian.
Thank you very much.
And then I'm just going to introduce everybody else.
Okay.
And then next, we'll hear from, that was my fault. Next, we'll hear from Jérôme Nassy, who's Senior Manager in Electrification and Power Transmission at Aker Solutions, who's going to cover the role of technical industrial skills in offshore renewable energy. So thank you for joining us, Jérôme.
Thank you very much.
And then finally, we'll hear from Joseph Lewis, Policy Lead at the Institution of Environmental Sciences, whose presentation will address how we can use the opportunity of skills in the sustainability transition to support a systems approach to levelling up. As a result, we'll bring together voices from academia, NGOs and industry to get a 360 perspective on the transition and skills involved in working towards a sustainable future. But of course, we cannot forget that sustainability requires a whole society approach. So these are conversations which we will need to continue and which will need to reach beyond the science community to address society at large. Approaches like education for sustainable development and carbon literacy will be vital to making sure we give everyone the understanding they need to engage with these issues so that we can all support change. And at my own institution, Manchester Metropolitan University, we've committed to embed education for sustainable development and climate change education in the form of carbon literacy in all our programmes, including our apprenticeships, by 2026. We also need an interdisciplinary approach, which is why it's such a pleasure to lead this panel discussion, bringing together voices from across the science landscape. To get even more voices in the conversation, we'll be following the presentation with a Q&A and panel discussion. So please start thinking of any questions that you want to ask, because I might pick on you if you don't come up with some. With all that said, I'm looking forward to the discussion as much as all of you, so let's get right into it. So over to you, Sian, to take us off.
Sorry to preempt.
No, that's me not being clear.
Thank you, Liz, and thank you everybody for being here, and thanks for the invitation to speak today. As Liz said, I am Professor of Environmental Geoscience at the University of Northampton, and I'm here today representing Universities Geoscience UK and the Geological Society of London. So I'll be talking about geoscience for sustainability. And I'm going to briefly outline the role that geoscience plays in sustainability, the sustainability skills that are embedded in a geoscience education, and the need for inclusivity and alternative pathways to access geoscience education and ensure there's a pipeline for careers in geoscience. Can I have the next slide? So the poster that you see behind me is a poster that was developed with the Geological Society and University of Geoscience UK to illustrate the role that geoscience has in a sustainable future. And you probably can't pick out all of the individual aspects of that, but I think you can see that there's a really broad range of areas here, all badged with the UN SDGs. There's some that I'd like to pick out, some key areas. So geoscience has an essential role in the energy transition and decarbonisation, the provision of sustainable infrastructure, so through engineering geology, ground engineering, geotechnical engineering, mitigation of natural hazards, including those that are related to climate change, so hazard management, and a breadth of resource management that includes water, critical minerals, and waste. So I'd like to think about how we're training geoscientists for these areas. So I'm going to go on to the next slide. So geoscience combines and crosses disciplines. It brings together understanding of biology, chemistry, physics, geography, engineering, informatics, and geoscience appears in all of these subjects in the school curricula, can be found in many aspects of the school curriculum, as well as in geology curriculum. Sustainability is at the core of a geoscience education. So I want to take a look at degrees in that area now, undergraduate degrees. The recent work that's been done to ensure geoscience degrees are current and forward-looking provides precisely the kind of skill set that's required for careers that deliver on the UN SDGs and to achieve net zero carbon. So the degree subject benchmark statement, which gives guidance to the content of university degrees, and accreditation that the Geological Society provides as a kite mark standard, have both been radically overhauled in the last 2 years to ensure graduate outcomes include knowledge and skills for securing sustainable future and awareness of the key challenges in sustaining a habitable planet. Now, some of those skills and competencies I've got listed on the board there. I realise those of you at the back might not be able to see them, so I'll just run through them fairly briefly. It's not all of them, but it's some key ones that I wanted to pull out. So those skills include observation and analysis that support complex decision making, especially in the light of uncertainty, the ability to recognise complex relationships through systems thinking, comprehending physical, chemical and biological Earth systems, learning from the past to inform the future, understanding subsurface with skills relevant to energy and resource management, and that's quite specific to geoscience, that subsurface understanding, working across a range of spatial and temporal scales, practical investigative skills both in the field and in the laboratory, multidisciplinary and interdisciplinary approaches, which that kind of understanding is critical competency for solving complex problems, and appreciating the importance of equity and inclusivity in sustainability. So now I'm going to go to the next slide, because here's the crux. The challenge we are facing in geoscience is not the deficit in skills that we have in geoscience education and geoscience for a sustainable future, but it's in the deficit of those qualified in those skills. The pipeline into geoscience and the limited number of graduates who have these essential skills. Together, so it's a double whammy here, with a lack of diversity of those who are studying geoscience. So the graph that I've got here shows the decline in numbers. So we're going from 2002 through to 2021 there. The blue line shows geology A-level entrants, and the red line shows those studying undergraduate degrees. And this is thanks to Mark Anderson at University of Plymouth, who shared the data with me. You can see there's a big drop-off after 2014, so that's what we're facing in terms of the pipeline. There's also courses that have closed in geoscience at a number of universities. If you look at countries across Europe, many show these decline, although the UK seems to have fared worse than other countries. And actually, if you look across the global north, and including Australia and New Zealand, many also show this decline. Geoscience is also one of the least diverse subject studies at university. And I want to give you some figures from a publication that was published last year in Nature Geoscience by Dowie et al. That looked at black and minority ethnic enrolment in undergraduate geology degrees. So they looked at a 5-year average up to 2019 and found that BAME representation in undergraduate degrees was around 8.5%, and for postgraduate around 5%, and it's particularly low for black students. If you just look at that academic year 2018-2019, and that's the last year they had data for, there's an improvement. It looks like figures are near 10% for undergraduate degrees. However, when you compare and contextualise that with students who are overall enrolled in UK higher education, that compares with 24.8% who are BAME students. So that's 10 versus 24.8%. So there's a problem in diversity and the lack of ethnicity in geoscience students. We have a public relations problem, and we have a public relations problem in attracting young people into geoscience and providing that pipeline to careers into sustainable geoscience. So I'm going to go to the last slide now. So we need to change perceptions of the subject, and there was a little bit of discussion around this in the session I was in before lunch relating to physics and chemistry. So it's not restricted to geoscience, although I think that precipitous drop that you just saw is quite restricted to geoscience. So I wanted to outline some approaches that we've used to increasing numbers and improving diversity, because I wanted to try and have some kind of positive spin on here. The first is through outreach and changing perceptions, and I've given examples of the GeoBus here and Geoscience for the Future that are outreach focused on changing ideas and preconceived ideas of what geoscience is. Also looking at early pipeline interventions, so raising awareness of geoscience in schools, but also training and resources for teachers. So, for example, Teach Earth, and the logo is down at the bottom there, is a set of teaching resources around geoscience, but for teachers that are in other subjects, maybe chemistry, biology, geography, and it's all mapped around key stages in education. So we try to make it as accessible as possible. And also Girls into Geoscience, which is focused on getting young women who are studying science into universities to learn more about geoscience. I've mentioned a little bit about the modernisation of the curriculum, and in that modernisation we've ensured inclusivity in the delivery of degrees. I've included the Equator project here, which is specifically looking at equity in postgraduate studies in geoscience. And I also want to know alternative routes, so levelling up by providing alternate routes into the subject area. And I'm going to finish by talking a little bit about apprenticeships as an alternate route. So we've just completed developing the standard of a degree apprenticeship in geoscience. And we've done that to try and address these pipeline issues and issues of diversity. And I want to say something about the role of degree apprenticeships in widening participation. So some of the data that's backed up our rationale for developing the degree apprenticeship. So firstly, if we look at educational background, diversity in prior educational backgrounds is a really characteristic feature of degree apprenticeship cohorts. They tend to have vocational qualifications such as BTECs. Secondly, degree apprenticeship students have a higher proportion of students from working class backgrounds compared to traditional undergraduate programmes. And there's some work that the University Vocational Awards Council did on that, and published some data on it. And thirdly, when you look at ethnicity, and I'm going to quote a study from this year from the Office for Students, from 2018-19 to 21-22 academic years, the percentage increase in the ethnic diversity of students taking a degree apprenticeship has increased by 19.8% compared to 9.9% on full-time standard undergraduate degrees. So there's an increasing number of those from minority ethnic groups that are choosing degree apprenticeships over standard degrees, where there's that choice within their subject area. Our hope in geoscience is that they'll provide a pathway to enhance diversity in geoscience through this degree apprenticeship. So I think I want to end there. Just a summary. Geoscience, essential for a sustainable future, provides key skills, some of which are unique to the subject area. But we face a pipeline problem of getting those young people into the subject area, into careers in geoscience. We need to change perceptions, and we need to enhance that pipeline through providing alternative routes and supporting diversity. Thank you. Thank you for listening.
Thank you very much. Thank you. So Jerome, lovely to hear from you.
Thank you very much. So I am a chartered engineer and a chartered environmentalist in the UK. So I've worked in the energy industry for the last 25 years, doing various roles, working for consulting firms and big industries, companies. So I'm working for Aker Solutions. So we are traditionally an oil and gas operator. So we have built up offshore expertise in the oil and gas. But as we are moving away from fossil fuels, we are transitioning into the offshore renewable space. So like we are transitioning into low carbon technology. So what does that mean? It means electrification and transmission systems. It means carbon captures, hydrogen, and of course offshore wind. We know the UK has a great ambition of 50 gigawatt of offshore wind electricity generation, which is quite significant. And then we are supporting the UK to become net zero, and we are supporting the UK to build up new infrastructures, mainly in the offshore space. So, and my role within Aker Solutions is to look at transmission systems and electrifications. So as you can see in this picture, so the decarbonization of existing oil and gas facilities require a number of low carbon technologies. So these innovative solutions, they include electrification. So we're trying to decarbonize the processes on the platforms. We know the oil and gas basins is declining in the UK, but we cannot just afford to stop tomorrow. So we still need oil and gas, that's a fact. But we need to try to help the industry to decarbonize. And by using electrification and different systems we put on the platform, we can decarbonize by 30%, which is 1/3. Which is quite significant. It's not 100%, but that's moving into the right direction. So the goal is to reduce carbon emission of these platforms using power from shore, electricity, and subsea systems. So we know that it's also critical to create an offshore power grid to be able to transport electrons. There are lots of offshore wind developments ongoing at the moment, especially in Scotland, but in England and all the different countries of the UK. And there is a requirement to create a meshed offshore grid. So we have an offshore grid inland, but offshore it doesn't exist. So every day we wake up and we open newspaper, they're talking about offshore winds, but nobody's talking about how can we create an offshore grid. And that's as important as developing and putting new turbines. Because if we cannot transport the electrons, then there's no way we will be able to achieve net zero. So there are lots of collaboration and work ongoing at the moment within all the different countries within Europe. We are creating this offshore grid. So one day there will be a lot of sunshine in Italy, and we will be able to transport all the electrons to Scotland. The next day there will be a lot of wind in Scotland. We will be able to transport the electrons in 1 second to Spain. So that's the goal. So this is building a new offshore infrastructure, which is absolutely critical. And the scale is absolutely huge. There are ambitions about 300 gigawatt of offshore wind in the North Sea. So 300 gigawatt of electricity. Just to give you an idea, this is half of the electricity demand of the whole of Europe, which is absolutely enormous. So, and this is a new technology. This is a new industry. We are trying to support the development of offshore wind, but we don't want to impact the local communities as well. So we cannot just afford to have lots of grid connections everywhere on the coast. There are people living, they would not be so happy to have like grid connection substations everywhere. So we need to sort of moving into the offshore space because there is only water. It cannot be seen from 30 miles away from the coast, but it requires new platforms. We need to convert the HVDC into HVAC. So it's enormous infrastructure, and this industry requires new skills. So we need a number of people with a lot of new skills like power engineering, policy supports, auditors, permitting and consenting, due diligence, regulatory engineers. We need to conduct a lot of feasibility studies. We need to look at different options. We also need project managers to be able to run these projects. We need health and safety quality managers. We need owners engineers, project management consultancy, and running different projects. So this is like a sort of a new industry. You have lots of unknown. We need to do a lot of R&D as well. So we want to have like a system, an offshore system which is interoperable and standardized, where you would be able to connect every kind of wind turbines with any kind of power assets. And this is also, we're looking at very high voltage systems, more than 500 kV, which is safety. There are lots of safety issues. And these systems are currently not communicating. So this is there is a lot of R&D to be done, and there is also a lot of projects to be delivered. Do you want to move to the next? So this is just another picture. So you see, this is more focusing on offshore wind. So what's happening in the offshore wind area? We are moving into floating offshore winds. So we need to design these new floaters, and the turbines will be of the height of the Eiffel Tower. So if you can imagine how significant it is. But of course we need to calculate. We need a digital twin. We need digital visioneering. We need engineers to be able to model, to do some modeling, looking at different options, looking at different issues on the swell, on the wind, and then afterwards we need to connect these systems and be able to transmit all the electrons across different parts of Europe. So this is a fascinating industry. It's not very well known. Everybody is talking about wind turbines, offshore wind, but the electrification, the transmission system is as funny as it is, and I really enjoy the work. So we need people with international backgrounds, open-minded, be able to go into different projects, be able to move from one area of the company into another area. So for example, we are developing as well subsea power assets. So this is the yellow triangle which is on the seabed. So we're trying to put all the different power assets on the seabed. So this is also an area of development in the world. And these systems are required everywhere in Australia, the US, in Asia. So there is lots of competition between the UK, Europe, and the world. We know that the US has launched the IRA, which is sort of putting the industry under lots of challenges because people would go away, industry would go away to develop these systems. But we need these skills, we need this competency in the UK and in Europe. So do not be afraid to go into engineering. This is my message today, because it's fascinating. You will be exposed to different projects, very complex. You will be exposed to different people, to fantastic technology. You will be supporting the net zero as well. I don't know whether we will achieve the 300 gigawatts, but this is an ambition in Europe, including the UK, which is absolutely enormous, and it will make a big change in our society. So my conclusion is really enjoy this work. Don't be afraid to go into, let's say, sometimes people say the dark side, which is power engineering, into a lab, because it's a lot of fun. And then you can, we have people starting in the company, they start as with apprenticeship, and they do they are involved in developing application. They do different digital softwares. They go they learn about digital twins. They do training and developments. They learn different things. We need people with a lot of technical skills. There's no discussion on that. And don't be afraid to go into a new industry.
finally, Joseph. Thank you.
Perfect, thank you. So it's this one over here. Okay, perfect. Sorry, so my understanding of PowerPoint comes from about the time that Sian's graph started in 2001, and I've not upskilled since. So the wackiness of the slides will now increase in direct proportionality to the quality decreasing. So I'm going to talk about place. I'm going to bring place into the conversation a bit and give you the most buzzword title presentation of the day as we talk about place-based sustainability skills and how we can leverage systems for a skills-led just transition. But we're going to go through what that means, hopefully, and hopefully it'll become clear. So the really important thing I want to do is start by taking us a step back and say, why do skills matter to sustainability? Not just how can we use skills that lead us to sustainability, but why are skills so important? And I'm going to do a little bit of the systems approach that Sian flagged up as a really important skill here. There's more on the systems understanding side than the systems thinking side. But it should give us a nice little baseline, and I should caution this is a very simplified systems diagram. So say you want to solve a societal problem like flooding. Well, the first thing you're going to think is, well, a lot of natural systems do feed into this. So very intuitively, weather does. If it rains more, then higher risk of flooding. Makes sense. Our watercourses matter a lot to the chance of flooding, because if we have rivers which are abundant with water, more likely that they are going to overflow. If they're very twisted around near settlements, it's likely they might overflow into settlements. If their banks are weakened, water might flow off them. All these things that make sense. And intuitively as well, soil also matters to our risk of flooding, because if soil is very compact, then we can expect it's not going to hold very much water, and therefore that water is going to be somewhere else and it's going to be causing flooding. So very intuitively, all of these things would influence the chance of flooding. But then we have to go a level beyond that, and we have to say, well, actually, the quality of our soil affects our watercourses, because if we said we care about the state of those rivers and the watercourses, then we care about what their banks look like and what they're made of and what the soil looks like sort of inland from those rivers. That's always going to have an effect on the watercourse. And then we'd say, well, actually, the weather also has an effect on the soil, because if we get a lot of dry weather, then it means that the soil is going to dry out, it's going to be less porous, and it means that the chance of flooding might increase. And then we're going to say, well, actually, the flooding affects soil as well, because if we flood, if we have more flooding, it washes away that topsoil, which is going to mean that we end up in a position where the soil that is left behind is of a lower quality, and then as a result, it all filters back through the system. So the important part to take away from this is we've got a complex natural system that is involved in causing this problem. And then if you bring in something like climate change, it affects all of these natural systems down the way into this problem. And as we all know, the things that are driving climate change are actually other systems, are socio-economic systems. So the economy, society, but also policy decisions, very importantly for today. All of these social systems are affecting something like climate change, which is then driving these natural systems to act in a way that is interactive, but ultimately causing these problems. And the reason that all of this is relevant is if we want to make a difference to how all of this operates, if we try simple interventions, they're not likely to succeed because they run into all of this chaos along the way. If you just say, oh, well, we'll make the soil fluffier, we'll put more water into it, that intervention isn't going to catch all of these complex drivers. So we need something that attacks this on a systems level. And so we need something that hits these key social systems down the right-hand side. And the reason that's important today is skills is exactly that kind of thing. It's what we call a key leverage point on this system. It's something that affects all three of these things intuitively, because the skills that we have determine the jobs that we do, which sets the shape of the economy. They shape our social understandings and the way that society operates, and as a result of that, they shape who we vote for, and therefore the policies that our society puts forward, and therefore skills affect all of these systems, which potentially affect climate change, which potentially are affecting these natural systems, as long as we have the right skills, and we use that as a leverage point that shifts all of this towards sustainability. And the idea is that if we bring these three things on the right together, economy, society, and politics, then they can come together in the form of what we call transformative change. And that is where we transform the system as a whole, rather than just taking I told you the PowerPoint 2001. But we take a transformative approach, and that's how we actually get away from this. So how can we do this in a way that is beneficial? Well, the good news of this is, if we are already taking an approach which is going to affect social, economic, and policy systems, then we can do other things at the same time that also affect social, economic, and policy systems. We can take an approach that deals with all these co-benefits at the same time. And so if we say that probably one of the biggest skills challenges is that there is a difference in accessibility of those skills, that some people have more access to skills than others, we can solve that problem at the same time that we address these sustainability challenges. And so we can get what we call a more just transition. This is just in the sense of justice, not just in the sense of only a transition. In fact, it's exactly the opposite of that. It's we do more stuff with the transition. We make it a fair one. We make sure that people get levelling up in the place-based sense of it. So that takes us really into, and you can see this is where the PowerPoint really falls down because the animations have completely fallen out at the bottom. This really takes us into the question of how we can use skills to get this kind of just transition by taking the kind of transformative approach. And on the left, you can see how can they support levelling up. And then on the right, it's the case study side. How can communities take on these skills so that they can make sure they're getting ahead of the picture and gaining the benefits of that? So the key reasons why we care. Why do we care? Why are skills important in this picture? Well, the first is early adoption. As we all know, if you have things before other people have those, you can take advantage of the marketplace and you have something that sets you apart. You can sell bigger than they can because you have more skills in your community. Very intuitive. The second is that it also works conversely to those economic systems, which is that you can get ahead of the economic change. So if the market is expecting people to have a baseline of skills, which requires an understanding of project management that wouldn't be a traditional skill that you might have if you are an engineer, perhaps in some ways, although engineers probably are very project management focused anyway. But you get the example. It means that those communities, if they develop those skills, will be better placed to deal with mass-writ economic change, as well as to have the chance at actually shaping that economic change as well. And then thirdly, and perhaps most importantly for a lot of industries, it also means that they are able to get ahead of regulatory changes. Because there's this general issue in policy that as regulatory change comes in, it benefits those who are the most advantaged, which means over time we see less and less accessibility built into the system as regulation changes. Therefore, if we can get communities ahead of regulatory change that is coming in inevitably, because we are expecting inevitable changes in regulation to lead us to a more sustainable future, it means those communities are less likely to be negatively affected by that and are able to comparatively level up. So there's two sort of really important things that communities can do and a few case studies here of how they can do them. The first of those is to build aspirations, because the really important thing is that no community is going to get to this place unless it has a whole community aspiration to develop sustainable skills and a sense of what that's going to look like for that community. It can't just be sort of copied across from other places. It needs to come from a willingness of the community to transition. And often the barrier to this is they don't have a sense of the stuff on the left. A lot of communities feel like they're not able to make this kind of transition. But hopefully what we've seen from the first part is, as we transition towards a sustainable society, there is a really big opportunity to do this kind of thing here. And so if you build that aspiration, it is going to be borne out and rewarded. And then the second thing, more practically, is to look at community skills audits. And the idea here is that you look at, and we had this a little bit this morning in the plenary, you look at the skills that you have now, you look at the skills you're going to need in your community in the future, and then you ask the question of how you get there, and you can put in place these plans based on that foresight. And there are a few good case studies of this. So Alberta in Canada has done a good job of transitioning exactly like in Jerome's case, from a more oil and gas heavy economy towards one that is focused on renewables. And exactly like Jerome's just told you about, all of those skills do transfer across in quite a logical way if you take the step of planning what that community is going to look like. And that means working with industry, including with industries that you might not think are invested in this sustainable transition. But of course, they still want to make money in the future, and therefore they actually have a really strong reason to be invested in this. And then there are other examples here in the UK. Ford Hall Organic Farm is a great example of how you can use community assets to build aspirations. So an asset like an area where people are currently socially and economically invested can be a way to build that aspiration of what this looks like in the future and why you would want your community to transition. And then Scotland also has done a good job of the framework level governance aspect of this through its skills strategy, helping to think about how you bring a small community approach into that big level. So I'd point you to all of that. So what are the key actions? Well, it's important we take a systems approach, like we say, but the key actions within that are that we take skills audits through to delivery strategies into transition pathways, like I've just said, that we have a whole workforce approach to literacy about data and systems and these things which are going to be crucial to understanding the ways that you can transition, that we have competency frameworks and tailored training to get the specific skills we need, and including in that technical standards. So if you were in this room this morning, you will have heard all about why we need technical standards to build trust and to be effective. But then we do all of the things that Sian said as well, which is that we have effective routes across education, including technical pathways, including lifelong learning as well, and everything else in between, because the whole community needs to be brought along with this as well. So the key messages for me are really simple, which is, the key message is really simple, I suppose, which is that skills are a key leverage point on our social and economic systems, so they need to play a key role in how we achieve transformative change. We should expect radical change to come in the face of environmental crises and technological development, which is going to change the way that we operate anyway. So we should use that opportunity to achieve social and economic equality as well. And all communities and industries can take simple steps to seize those opportunities, and so we should construct policy to facilitate that change wherever we can, and as individuals we should seek to seize that. So that's it from me. Thank you.
Thank you very much to our speakers. Do we have any questions? Yes, please. Could you just say who you are as well and where you're from? And we just need to wait for the mic. Thank you.
Can you hear me? Okay, yeah. I'm Sabrina Fleury from the RSV, so Royal Society of Biology.
If you could speak up for the room as well, because that mic is just for the recording.
Oh, sorry.
So, yeah.
Can everyone hear me now? Okay.
Thank you.
So I'm Sabrina from the Royal Society of Biology. I have a question. I have two questions, actually, if that's another issue. The first one is, do you think that, more tangible elements from climate change represent an opportunity for maybe more people to pick up geosciences? Eventually, like seeing, those effects of climate change, more, maybe a younger generation might feel more enticed to pick up those studies so that they can make a difference and make a change, and that eventually we would only be able to measure the impact a bit later on. So, the curve that you presented will, slightly shift, but not now, maybe in 5-10 years from now. Mm-hmm. So that's my first question. And the second question was more for Jérôme. It was about how much do you work with environmental, scientists when it comes to establishing all these, new technologies. So how involved are they? Are they just involved in the, primary phases, or are they, are you, in contact with them all throughout the projects?
Thank you very much. So, Sian, would you like to answer the first question?
Thank you. Yes, so I think what Sabrina, to paraphrase it, sort of what could make younger people take up geoscience. Well, I think geoscience, geology, earth science, however you label it, suffers from a big public relations challenge in that the perceptions are that geologists drill for oil and they dig up coal, and if you think beyond that you might think of dinosaurs, and really that's it. So I think a lot of this is trying to change that perception through some of the initiatives that I mentioned, but also within our school curriculum, geology is within other subjects, but it's not often identified as such. So one of the things that we've tried to do with this Teach Earth initiative is to map where geology sits across school curriculum at GCSE level, at A level, and then badge it as such. Say, okay, well, if you're teaching biology and you're teaching this particular aspect that overlaps with geology, maybe it's to do with using an old term here, but continental drift and evolution. Well, this is actually geology, and here's some resource you can use if you're a teacher. So it provides resources to teachers that have not necessarily had any kind of geological training, but it also badges it as such. So it's badged with GSL and UGGK to help young people understand that this is actually what the subject is about, so to change those perceptions. I think another challenge has been, and I'll try not to talk for too long, is that we've lost AS levels, and AS levels used to be a way for students to start to study 4 subjects at A level when they weren't sure which ones they wanted to do, and often they might pick up geology because they quite liked geography and they were quite good at science. But as those have gone away, then that drop off does quite coincide with the loss of AS levels. So that's something else. That's a reason. But it's changing the perception both in school and then outside through media, social media, the initiatives I showed there. It's a big piece of work, but we've started on it. Hopefully that answers your question.
Thank you. And Jérôme?
Yes, so environmental science is definitely a key part of these different projects. So, for example, if you look at the projects, you start with a feasibility study, which is like working on a computer and looking at different options. How can you put an infrastructure offshore? But then after that, you move into a single option and you do like very detailed studies where you look at what's the condition of the seabed. Then you need to understand that. You need to do some drilling sometime to test, to see whether it's stable or if there are any issues, to put these very heavy platforms. Sometimes they are like, we're talking about 8 or 10,000 tons platform, so this is enormous, so you need to make sure it is going to be stable. And then afterwards, we're working with meteorology agencies. So when we do install these equipments, we use very, very heavy vessels. But of course, we cannot just go on the sea and just when there is a storm, we have to wait. When there is a possibility to go there and there is a good weather condition to install these equipments. Decarbonization is also very important. So all the industry, all the customers, whether they are wind developers or whether they are oil and gas, they're asking to look at decarbonization. What's the impact of a single project on CO2 emissions? So when you want to do something, we need to calculate what are the different CO2 emissions, not from doing these projects, but also from the supply chains, from the raw materials, from the people, from everything. So CO2 and decarbonization projects are very, very important. And then when you think about CO2 emissions, you need some environmental sciences models, you need some support from environmental sciences, especially if they are very, very complex and large projects.
Thank you. Can I ask a supplementary question? Do you also look at the biological impact, so the environmental impacts on biodiversity? Because that would be a good place for biologists to get involved, and that's obviously very important to people in the room, I should imagine. Yeah,
so very, very good comment on that. So, for example, we have done some studies. For example, if you install like a new platform, an electrical platform, offshore wind turbines with jackets, we have done some studies, and we know that there are biodiversity developments on all the jackets, on all the jackets and the tubes. So we know that it's just create a new form of biodiversity on the sea. Absolutely, yes.
Okay. Any other questions? Yes, please. Or you, if you want to go first, we'll just get the mic and we'll come to you later. Thank you.
Okay, can everyone hear me?
Yes, thank you.
So thank you all for your presentations. Really interested in kind of the leveraging skills and particularly around the systems-wide approach. I think that slide really captured kind of all the different nuances and the complexities in the system. Also really interested in the community skills audit that you mentioned, Joe. And, you know, this, what do you have, what do you need? And I suppose about the retention, retraining and upskilling and also the attracting people. And I wonder how the community-led aspect, or perhaps a slightly devolved aspect, tensions against kind of wider national need to look at it, you know, whole scale. But also thinking, I suppose, around the advantages that place offers in thinking about where our strengths are at the moment and really leaning into those strengths, you know, where the universities, the organisations who are working together and to lean into that. I think final point, I'm starting to think around kind of skills mismatch as well, particularly within regions. And, you know, I expect maybe a community audit might address some of that, but how can we go about avoiding skills mismatches as well? So quite broad questions, devolution and how this kind of sets across the national agenda, skills mismatches, and how can we lean into strengths that place might offer us?
You happy to answer that one?
Yes, well, thank you. I think a great question. So there's sort of two answers to the first half of the question, which I think somewhat speak to the second half of the question as well. Because I think you're right that the community skill audit is how you want to address that mismatch potential. The first thing, though, is how do we deal with that in the context that the national or supranational picture is not always lined up for it? The first element that we need to address this is a sort of framework level governance approach to it. So we need something that ties the national level down to the local level. So this is for when you have got a commitment at the national level, there is a desire to move in this direction, and you're looking to line up the opportunities that wouldn't otherwise necessarily work. So we need to find ways to align with sort of the overall commitment, and that stems from, one, if you've made that commitment at a national level, you have a desire to see it delivered, and it's not going to be delivered by you, it's going to be delivered by different communities. So it's about drawing that link between policy design and delivery. Where it doesn't exist, it's a little bit more difficult. But as you've seen from the fact we have case studies on this, it's not impossible, because there are a lot of policy regimes where this isn't happening on the national level, but nonetheless people are able to make some progress at a more local level. This sort of reaches into the community skills audit question as well that you asked. It comes from a starting point of determining what your community is and what the centre points in your community are. Because a lot of the time that will be local government. I think a council in the UK that's doing a very good job on this is East Sussex, are doing some great work on this. And they've literally taken this audit approach. They've reached out to organisations to say, do some surveying, find out what skills we have, find out what people's vision of the future is, and they've taken that very logical approach to it. And they've done that with some degree of national recognition of targets, but without this being something that is given to them by government. So it is possible to do it without them. But a lot of the time, you aren't going to have... Local government isn't going to be able to play that perfect role as the centre of the community. So you will be turning to things like academia will often be a place where the community comes together. But so will things like national parks, World Heritage sites. Anything that is a centre point for the community could be a staging ground to begin these conversations about what does the community look like now and where can it go forward. And there's a little bit of best practice that you can use to try and achieve that. And because none of these organisations, because they're all strapped for resources and time and they all want to do something good, they have an incentive to fight back against mismatch. They're not going to say, let's go for skills that are unrealistic for this community. So big issue, but hopefully I got a little bit of that answer in.
Thank you very much. And we had a question over here. So Ethne afterwards, if that's all right. Yeah, thank you.
My name's John Lowe. I'm on council for Institute of Mechanical Engineers and a couple of other things. And in particular, I helped to run an industrial museum, which has got a national top award for what we do in STEM outreach. But I want to come back to this, the very focus of this particular session, and that is I would suggest that there's nothing special about geosciences. What we're looking at is a shortage of STEM recruits, and I'm talking at entry stage. I'm talking about primary school onwards. Our real problem is we haven't got enough feedstock going into the education system. For decades, and it is literally decades, we've been struggling with STEM schemes, and there are masses of them out there. We have had support from professional engineering institutions, Gatsby Trust, anything you like to name, but we haven't moved the needle. And the graph in the first presentation showed, in fact, that in some sectors, it really is dire. UK can't sustain itself unless we crack this problem. I'd like to know what the panel thinks is, what can we do to resolve the underlying problem of not enough people taking up STEM careers?
Okay. I've got a suggestion, but does anybody want to answer that one?
I know the answer, of course.
Oh, good. Well, you can give me the answer as well. But shall I say something? Yeah. This might not be the sort of solution, but it's one potential solution, in that the government recently published a sustainability and climate change strategy that was trying to really introduce connections with climate, nature, data handling, all some of the intrinsic skills that have come through all the presentations we've had so far today, the sort of shared skills and the curiosity and the tools to carry out investigations and the passion to do so and the sense of belonging that this is something that matters to me. And so I think if we can recognise that there is a need to do that and encourage all schools, from nurseries to schools to colleges to universities, to engage in this process, that may be a solution. However, it really depends on mechanisms that make that happen. So it's not just an add-on, it's not a nice to have. There are drivers in the system that really make that happen. A bit like you were saying, I was at a recent International Green Skills Conference where they were saying, well, Liz, you're lucky at universities because there's loads of data to show that students are really interested in sustainability and they're really interested in making a difference. But if you go to schools and colleges, students really are not that engaged. They don't really understand how it relates to them. So there were lots of suggestions about universities, schools, colleges, right down to nurseries, working really closely together to get people in as role models from industry, but also crucially students. I think young people are really strong advocates for the roles that you can take. So it's about having this pipeline of activities that really show people what it means for them. Now, that all sounds, and I'm saying it, but it all sounds rather wishful thinking because it's all these things that we've tried before. But I think it's now recognised that it's got to be something that's embedded holistically throughout all areas of education to try and engender this change. And I think one of the hopeful things is that government does seem to have noticed that it's a big issue, and they've tried to look at ways to address it through this sustainability and climate change strategy. I think it's actually going to be up to a lot of people to work very hard to make sure that happens and it doesn't just become another scheme that really didn't work. But I'd be really interested to hear your answer of what we should be doing as well and see what other colleagues have got to say. But yeah, so tell us the solution, because you're obviously very wise, so tell us the solution.
No, I'm not really very wise, but I have been promoting STEM for a long time, and I've had some recognition for it. And there are a number of key messages, and if you look at the Perkins report for the professional engineering institutions, you'll find much of this cropped up then. Certainly, I'll just give you 3 or 4 things. One, you've got to be consistent. We chop and change all the time, and we change our priorities. 2, you must have it backed by a government that really has vision. I'm not being political, but we haven't had a government with vision in this country for a long time. You've got to look at the efficiency of schemes, that they have a long-term effect. Longitudinal studies will show you that, for example, in engineering, green power works, but one day playing in school with hands-on toys is eclipsed by next day's exposure to musical excellence. You've got to have teachers, and in this building they certainly know it, who know about the subject they're teaching. Physics teachers are notorious for only a small proportion are actually physicists or understand physics. You've got to have careers advisors, and you've got to actually pay more money. Engineers have been undervalued in any sorts of disciplines. There's more than 3 or 4 things there, but if they are captured and the professional institutions and bodies like this one can come together and write that manifesto with even more strength than the Perkins report, you might get somewhere. But bring it together, be consistent, and put some of those things that I've mentioned, and there are more, into the ground rules. Thank you. By the way, in my museum, we focus on STEM, and that has raised our numbers visiting us from a few hundred to 15,000.
Congratulations.
And we've, as I say, won the top award for what we do in education outreach. I do know what I'm talking about.
I'm sure you do. Thank you very much indeed. Ethne, you have 30 seconds to ask a very quick question, and the answer has to be a minute.
Okay,
Yes,
Sian, this one's for you. So you mentioned perception and diversity are two issues facing the geosciences. One reflection of mine is that role models are important for perception and diversity. So I wonder what thoughts you have around how we can use the current workforce and upskill the current workforce so that there's more diversity in leadership positions in geosciences to help with that diversity in the pipeline.
Thank you.
Oh, that's a good question. So one of the challenges is because the lack of diversity has been inherent in geoscience for a long time, there aren't a lot of role models. I remember when I was studying for a geology degree, there was one woman who was a lecturer in the department. So it takes time. So I think rather than looking for those who were further in their career, I think it's looking for those who are early career geoscientists who do represent diversity so that young people, teenagers studying science can see themselves in those. And I think that's probably where the answer is.
Fantastic. Right. We have 2 minutes.
May I add something?
Please do.
Yes,
of course.
regarding that just previous question, I think I would be keen to see more placements. So, for example, when you have teenagers or youngsters, they would be offered like 2-3 weeks placement in an organization, public or private. They go there, they open their eyes, and they may discover a role model. They may suddenly say, oh, I like this or I don't like it. But this is like discovery, helping the education system to go into private companies, industry, public companies, private, etc. Just discovering, opening your eyes. Just you don't know whether it's for you, but at least you have an opportunity to see something.
Thank you. One thing that's worked quite well at my own institution, we did a Faces Of campaign, and we had to look across the sector and not just in our own institution, but we looked at faces of bioscience, faces of environmental science, faces of engineering, and it's almost like this subliminal curriculum. We've got images of all sorts of different people in really exciting roles just dotted around the campus, so you can't help but miss it. So you will see somebody who looks like you doing something really exciting every time you walk past, and you think, oh, actually that could be me. So I think it's about getting everybody involved in that process. So I think that's very important. Right, 1 sentence each. Is there anything that you would like to sum up with that you haven't summed up with already, or are you happy with what you said? Sian,
I did want a quick response
Yes.
to the talk about what do we do to encourage young people.
Yeah.
I think it's in that STEM curriculum, we need to take that spark of curiosity and exploration and really build on that and not kill it, which is what I think we tend to do at the moment.
Yeah. Jérôme?
Yeah, for me, it's really at a young age, like 15, 18, 20, just being exposed to different environment, just have the opportunity to spend some time in different environment, different departments, and then you discover, you learn, and you may discover role model. You may say, oh, this is me. I want to do that, and that's very important. Otherwise you don't understand, because you. For example, my son or my children, they look at me, they really don't know what I'm doing because they've never been to my company. But if I can talk for 2 hours, but just for them to go there and have a look would make a big change.
Thank you. And Joseph?
Yep, along very similar lines. I mean, we spend a lot of time at work, so our jobs are a significant part of our identity, which means people won't do jobs unless those jobs align with their values, unless people think they align with their values. So the biggest shift we need to get people in the STEM workforce for sustainability and for the transition is to make people have an understanding that these are jobs which align with their values, and that the skills they need to do those jobs, such as being a geoscientist, align with those values. So I think my final takeaway is just to go back and look at Sian's answer to Sabrina's question at the beginning of the Q&A, because I think that summarises it for me exactly on the
Would you like
running.
to paraphrase it?
I've kind of paraphrased it in the lead up to that, Liz.
That's all right, then that's fine. Thank you very much. So I'd love to thank our panel, and I'd love to thank our audience for your fantastic questions. So thank you very much, everybody.